In our last video discussing periodic table trends, one of the things pointed out was the further we go down the periodic table, the greater number of electron shells or energy levels. Specifically, the row number of the periodic table, so first row, second row, third row, etc., the row number tells us the number of energy levels. So as we go down, every time we go down a row, we're going to add an energy level. But what happens when we move from left to right on the periodic table? So we already said that as we go down, the number of energy levels increases. But what happens when we move from left to right? And that's what we're going to be talking about in this video. So let's look at our elements. Let's start with let's do these third row elements. So these third row elements are going to tell us third row. That means there's going to be 3 energy levels. And let's start with this first one of sodium. So I'm going to go back to our notes that I provided for us when we were doing orbital diagrams and Bohr models. And let's scroll down to our example with sodium. All right, sodium right here. So this is what the Bohr model and orbital diagram for sodium looks like. And ignore the number of neutrons. It doesn't matter what isotope we're using. Neutron number is not going to matter for what I'm discussing right now. But notice that sodium, we know that the atomic number is 11. So that tells us that it has 11 protons. And since sodium is uncharged, it has a total of 11 electrons too. We know that the most electrons that can fit in the first energy level is 2. The most electrons that can fit in the second energy level is 8. And then we are going to add that 11th electron on the outermost energy level, the valence shell, because the other energy levels are full. But what happens when we move from left to right on the periodic table and we come to magnesium, the next element over? What's going to happen then? Well, magnesium has an atomic number of 12 instead of 11. So we know that it has another proton. And if it's uncharged, that's going to mean that it also has another electron. But where am I going to add the extra electron? Am I going to add it in this first energy level, in the second energy level, or am I going to add it in this outermost energy level? Well, we already discussed that those first 2 energy levels were full. So that means the only place that we can add it is this outermost energy level. So we said for sodium, the number of valence electrons is 1. If we scroll down to magnesium, we're going to see that magnesium has 2 valence electrons. So no place for the valence electrons in this first energy level, in the first energy level or the second energy level. So we're going to add it to the outermost energy level, and that brings the number of valence electrons for magnesium to 2. So maybe pause the video for a second. What do you think is going to happen when we have 13 protons? When we move over to where aluminum's at, we have 13 protons. That's going to mean that we have 13 electrons. Where's the extra electron going to go? Is it going to go in the first energy level, second energy level, or the third energy level? Well, let's see. We've got it drawn right here. And for aluminum, we're going to add the electron to the third energy level. So the valence shell. So now the valence shell, now we have 3 valence electrons in the valence shell. What if we add another electron? Well, we're going to move over on the periodic table 1 more to the right. Now we have 4 valence electrons. What if we add another one? Now we're going to have 5 valence electrons for phosphorus. Move over again. We're going to add another electron to the valence shell. And again, we're going to have 7. Then for argon, we're going to have 8 valence electrons. So we might notice some sort of trend here. We might say that on the periodic table, when we go from left to right, the number of valence electrons is going to increase. Specifically, when we look at valence electrons, we can look, if we want to cross off this d orbital for now, it's kind of, it's a little bit of an exception, and we'll talk more about it later. But the number of valence electrons is going to correspond to the column number. So 1, 2, 3, 4, 5, 6, 7, 8. So the column number, when we cross off this part in the middle, the column number is going to tell us the number of valence electrons for an atom. And it's so as the atomic number increases, we are going to have a greater number of valence electrons. But that's not always the case. It's always going to be the case where the column number is going to tell us the number of valence electrons. But you might say, well, neon has 10 valence electrons, neon has 10 total electrons, and sodium has 11. So does sodium have more valence electrons? Well, instead of just looking at the atomic number, let's look at where they're located on the periodic table. Sodium is located on the first column, and neon is located on the 8th column. So the column number is really what's going to be our best friend in determining the number of valence electrons. Later on, we're going to talk more about valence electrons and how to draw Lewis dot structures. So the dots are going to represent the electrons, but we're going to do that in a later video. So hopefully we can understand valence electrons. All you're going to look at it is the column number, and that's going to tell us the number of valence electrons.